You taint the clothes.
Okay.
You dye the clothes. So you can call me the dyer.
Isn't there like an English variant of it?
Chemo, you ground cochon.
Is there an English variant that we can use?
Well, how do you call the guy that gives colors to the clothes?
The dyer. Dyer. You said it right. Dyer. Yeah.
Is that fine with you?
Hold on, let me.
Chemo, you're supposed to say Je m'appelle dickhead.
Oh, you're also in the UK?
I don't know. Sorry.
Oh, it's not important. But the Earth is not a globe. You know that?
No, I disagree.
What?
Chemo, say Kilera Teal and then say 10.
How on earth can you disagree?
What is it if it's not a globe?
Where's the evidence for the globe then? Get straight into it.
What is it if it's not a globe? Is what he just said.
No. Let's get the evidence for the globe first.
Yes. Everything you see in the sky.
No, the globe, not the sky, dude.
Yeah.
Yep.
Yeah, everything that you see in the sky makes sense if you're on the globe. I don't see any other...
Why doesn't it make sense on the flat Earth?
Everything. You just have to look up. Like, why does the sky rotate around you as you move around the Earth if you're on a flat Earth?
That's your... Sorry, I got the hiccup. That's your model, right?
Yep.
Yeah, but you know models are reification, right? It's a fallacy.
No, it would be only if I said that the model is truth, is the reality.
What is your model then? Does it represent reality or not?
Does it represent it? As best as I know, yes.
How so?
Because every prediction that I can make from the model is corroborated by observation.
Okay, so let's look at the sun. Where does the sun go at night? Once it goes beyond the horizon, where is it?
On the opposite side of the globe.
Okay, that's the model. How are we going to demonstrate the sun is actually below the horizon?
How do I demonstrate that well, I can call my friend on the other side of the globe and ask, do you see the sun?
Yeah.
Yeah, that could be a good prediction.
You know, when the sun sets, it appears to set. Looks like it's going down, right?
Yes.
How much investigation have you done on that question?
Just basic observation from my eyes.
Like when you see the sun, it appears to go down, right?
Oh yeah.
But the horizon, what do you know about the horizon?
The horizon is the furthest point I can see with my eyes.
Yeah, but you know it's not physical.
What?
Physical, like the horizon is not a physical place. You didn't know that, did you? See?
It's a mental construct, like it's.
We're gonna learn a lot today, Latentio, because I used to think the same way that you think, like the sun's going behind the horizon and going down the ball and around either side. But what we find is because the horizon fluctuates, understand? Fluctuate?
Yes.
Yeah. When things appear to go beyond it, okay, this is just an illusion.
Yes, okay.
So the sun actually stays above the ground all times, and it goes beyond what we call an apparent obstruction. It's not a physical obstruction, apparent obstruction.
So it stays above the horizon all the time?
All the time, yeah. Well, the horizon is not a real place, it's not a real thing, right? The horizon is just where the sky appears to meet the ground. And as the sun reaches that position, it goes beyond an apparent obstruction. Okay?
So the horizon is an illusion.
Yes. So like I said, if you're, for example, if you're 1 foot and your geometric horizon is 1.22 miles away, then see things disappear from 1.22 miles away. And the next day, things can disappear 10 miles
Right.
away.
So
20.
when I call my friend on the other side, it's not the other side. It's just since the sun never came down, he sees the sun, but I don't see it because he doesn't have the same horizon as me, right?
No, the only reason why you don't see it is because of the apparent of. See, in the globe model, there are lots of apparent versus actual. So, like gravity, for example. You heard about gravity?
Yeah.
We know you have an acceleration.
Yeah.
So it's not an actual acceleration; it's an apparent acceleration. You know, like the force of gravity. Not an actual force, an apparent force, like a pseudo force.
Right.
You know that, yeah?
Yeah.
Yeah, you know that. So when we're talking actual versus apparent, we have in your model an apparent horizon when it should be physical. Have an apparent sun when it should be physical. We have an apparent acceleration, apparent force, apparent rotation. Everything is apparent. It's not actual. That's why I say the model is a reification fallacy, right?
But you still have the rotation of the Earth, right?
No, it's an apparent, because what we have is the gyro thing, device, whatever you guys use. Now you say this tells you the Earth is what? Ring laser gyro, yeah.
So
Bob's gyro, yeah.
What accelerates the pendulum to rotate?
But that's the
Is
thing.
also an
See?
apparent.
We can
It's an
assume.
apparent force?
We can say fairies. We can say unicorns. We can say Earth. Say anything we want. But for it to be scientific, we would have to manipulate our independent variable.
What?
Understand these words? Independent variable.
Wait, if you can come back to the previous topic.
Okay.
So the sun and the horizon, right? They're illusions.
Well, in your
Do you
model, yeah, because the sun is not the actual sun that you're looking at. You're looking at the apparent sun. When you see
okay,
it
so
go down,
there's let me see if I get your point. So
Mhm.
there is some kind of disturbance of the light rays that come from the sun, so that we see it coming down under the horizon, but in fact it's not under the horizon. That's your point, right?
yeah, it's not actually going down. It just appears.
It appears to come down.
It
Okay, so
appears to go
this transformation of the light rays, you have a formula that can like accurately predict how it will bend the light rays or something?
That would be a model. Spoke about models, yeah.
Yeah, you
Models are
said it's
reifications.
yeah, the reification fallacy. If you claim that your model is reality, that's the
Like what
reification.
you're doing. You're claiming the
No.
horizon.
I'm asking if you build a model, a conceptual model, to help you put out predictions and have a predictive power. That's not a reification fallacy. It's a reification fallacy if you claim that the model is actually what happens in reality and how reality behaves, right?
Exactly.
So as long as you keep saying it's just a model, I'm not talking about reality, I'm not talking about truth, I'm just making
the
a
flat
model.
Earth,
That's not a
though.
reification fallacy.
Flat Earth can't be modeled the way light bends.
Why not?
Why not?
Why not?
Have you seen Walter Bislin's model, flat Earth model?
Yeah, I've seen Walters.
No, but have
What
you
does that have to do with it?
Latenia, have you seen?
No.
Right.
So
Walter Bislin's made this old flat Earth model, but the
can you
light.
spell the name? Sorry.
I'll get it for you now. I'm going to get it for you. I'm going to get the model for it. Right. Now
Walter?
this model explains everything.
I can't wait.
Yeah, everything. But doesn't accept the way light
Behaves?
bends. So let me get you oh, here we go. Here's the model. Working model.
You can still bloody hear, you know. You can't just go breaking words up or something. It's like, yeah. I'll let you off for that one. Go on, carry on.
This model here explains ellipses, equinox, daylight.
The only reason why I'm not interrupting Cumulus because I know what you're up to, so I'm just being quiet. There you go.
Goals. Have a look at this, Latinia. Right?
Yes.
This flat Earth model here explains everything that you need to know. Now, obviously, you have two choices in life. You can either go with gravity, which is not a force, which can't be demonstrated practically, or way light bends through the air or the atmosphere. Now, the guy who made this model is like, well, it works, but I don't accept how light bends. In extreme forms of light bending.
You don't accept?
No, because again, models are a reification. We don't have a model. We don't want models. We don't need a model. But there is a model here. If you're into models, then this can help you.
Thank you very much for this. Seems very interesting. Actually,
yeah, that's what I'm saying. But again, the guy who made it is a globe earther. Okay, he doesn't agree with this model. Like, well, like I said, the light has to bend in certain ways and stuff like that. Or, like I say, you can go with gravity, which we know is not a force. Or we can go with the light bending, which is very difficult.
So, like, this one thing that this model doesn't seem to explain very much is the stars, right? Because you have the sun, okay? That seems...
Stars, it says stars. Click on stars. Go to the top where it's got the menu, click on stars.
Wait.
Of course it models the stars. Take a look at this.
Ah.
Click on stars, friend.
Okay.
Yes,
I found it.
You see?
Oh, but
Learn
it only
something
rotates...
new every day. Right?
It only rotates around the North Pole.
Yeah, you like that.
Well, what about the southern?
Yeah, because you got your old personal dome. You know? Now again, I don't accept any of this because models are misplaced concreteness, right? And you'd have to assume the height of the dome, assume the stars, assume the sun, all that stuff. Yeah.
But I mean, in general, if you want to make predictions, models are very useful, no?
Not really. I mean, it's not really going to benefit you in any way. It'll just give you a little bit more knowledge about where you live, but I mean, you've got the stars.
I would say it's the only way to actually have, like, how can you pretend you have any understanding of the world you live in if you don't have an accurate model that helps you make prediction?
What are you trying to understand?
Pretend is the important word there. Pretend.
See, for example, Latinia, this guy here, Dr. Nemesis, okay, he owes me £2,000. Okay, we had a bet some time ago. Listen to what he said to me, Latinia. He was like,
I'm still going to do it, Ken.
Oh, you know what I can do? I can navigate any... See, well, let me talk now. Friendly muting me. Friendly muting me now. You see, Latinia? Because the heat is on. You see? And he lost a lot of money here. The heat is on, and he won't let me finish and make my point. You see?
Because he's fucking on one.
Very rude. Because he knows, Latinia, that what I'm about to say is very damaging for his argument. So he was like, Chemo, you know, of course the Earth is a ball because all the moss grows on the north side of the trees everywhere around the world. And I'm like,
tell the story,
dude, what are you on about? He's like, yeah, I can. First of all, I bet you that the moss is on the north side of the tree, of every tree, the north side. And then he said, that's £1,000 bet. Then he said, I'll bet you another £1,000 that I can travel anywhere in the world using moss from like anywhere to his house. You understand?
Kimo, I know it's an open channel and I can't ask for having a one-on-one discussion with you, but
no, it's not. I'm telling you.
Right, but can we go back to?
It's probably bloody live as well.
I'm explaining to you, Latinia,
Can we go back to our discussion?
Yes. Okay.
Yeah.
Let's not have a one-on-one with Sci-Fi. Let's have a one-on-one with you instead.
So,
models.
Yes,
We've got the model for you. Yeah.
So, I would say, like, if you don't even accept that in your reasoning You include modeling, like you cut yourself from every hypothetical reasoning, and any hypothetical reasoning is cut off from your ability to reason. That's you're shooting in yourself in the foot, right? It's like hypotheticals are the basis of human reasoning since human can reason. No.
Well, the thing is that we work on the really is level. So there are no assumptions. We're not presuming anything. We're either going to measure it, and if we don't know something, we have no problem saying, hey, I don't know. Whereas you guys find it very hard to accept when you don't know something. So, for example, if you can't get out of the enclosed system, that's very hard for you to take. It's like, no, we can get out of the enclosed system. You know, if we say the Earth is not turning, oh yes it is, we can, you know, you find these things very hard to accept. That's what we're talking about, that really is. Now your model might say the Earth is curving, spinning, flying through space, but in reality, Latenia, can we really measure curvature? Right?
Yeah.
Now we know, or I know at least, that nobody on Earth ever, not that you can provide or I can provide, of anyone measuring curvature of the Earth.
That's easy.
Okay, let's get it on. Post me a link. Post me where they are measuring the Earth curve.
Okay, give me 1
I
sec.
don't mean like I want to see people at work doing the stuff, actually measuring Earth curve. Can't just blind faith believe that someone wrote down, I measured curve, I measured this much on this day, and then I measured it was really curvy, real curve on this day, nice curve, yes, I measured curve.
He had a fucking big tape measure, didn't he?
Yes, one can measure the curve
Yeah.
of a table by looking at...
What do you have? A 6,500 foot fucking tape measure? I mean, how big would that roll up to, mate? Come on.
So basically the answer is you measure angles.
Okay.
Excuse you can't just ignore me like that. Sorry.
I'm not ignoring you, Tad. Alright, so let's look at your video here. Are they using the Eratosthenes method here?
Kind of, because Eratosthenes uses the sun. I don't use the sun.
You don't use the sun here. Okay.
Do you want to do it with the stupidity or without the stupidity? Because I can be quiet if you want.
So look, in your video, at 1 minute 55,
Right,
go to 1 minute 55 in your video.
Yes. Yes, tell me.
Okay, so there's a curved surface, yeah?
Mm-hmm.
Where did that curved surface come from? How do you know the Earth is curved like that already?
Well, I was looking at my ass cheek and I thought, that curves.
That's not the question. You asked me how do you measure it.
Sorry.
No. You've already got...
Taking your train of thought away
you
from
can measure it by
ass cheeks
presupposing the radius. But I'm talking about real world... Yeah, again, look, you show me a model here. A model.
But this isn't the real world, is it?
And
this
you're
is just a chat room.
And you're presupposing curvature already. Okay?
What's the problem?
Well, has anyone actually measured the Earth's curve directly, like outside?
Yeah, they have actually.
Yeah?
So you can measure it also by with the seismic probing.
How do they work?
You send well, actually it's usually with earthquakes. You measure the arrival of the tremors from earthquakes in different parts of the globe, and then you try.
Maybe you can stick 2 sticks in the ground and divide the flaming distance in the middle. It's easier.
Keep on presupposing a globe without actually measuring the curvature.
Well, this is what I said earlier. Like the reason I know that we're on the globe is because this is what I started the conversation with, because every predictions made through the globe are corroborated by evidence, by observation.
All right, let's take a
If
look.
if
All
you
right.
make predictions that are contrary to the globe model, and you get corroboration with observation, then your model is, it's indication that your model might be correct.
Go on then, hit me with a prediction. What have you predicted?
I predict that if I move south on the Earth, I will at night, right? I will see the sky rotate around an axis that is orthogonal to my direction of movement. Right?
Go on then, give us a look then. Let's take a look at this. Go on, I'll have a look if you've been round to the south of me. Go on. Twisting my arm.
What do you mean? This is my video, right? This is what I explained in the video.
Yeah, but I'm saying this is just a I'm talking about the Earth, actual Earth.
Yes. If I move on the Earth and I look at the sky and I travel south, I will see the night sky rotate around an axis that is orthogonal to my direction of
Where in
movement.
your video is that at night?
In the video, it's at starting at 3:33.
3:33. That's a flat Earth.
Yes, because this prediction doesn't presuppose that the Earth is round, right?
Let's try this again. The real world outside of your house, yeah?
Yes.
Has anyone in the real world measured curvature?
Why does it have to be outside his bloody house? The real world is everywhere, you nugget. Now get back into the bloody real world.
Astronomer, anybody that has been paid to watch the night sky, like every astronomer is following, making the calendars 2,000, 3,000 years ago. If you came and tell them that the Earth was flat, they would laugh at you because
Probably.
they knew.
But all I'm asking is a very, very simple question.
Probably bloody lock you in the tower.
Not very difficult.
Poor Galileo.
All I'm asking is, in the real world, outside, on the ground, anyone measured the curvature?
Yes, it's the third time I answered the same question.
Okay, so let's stop there then. Stop there then. Let's take a look.
Could be a fucking fourth as well.
Measuring the curvature. Take a look.
Yes, that's exactly the same thing I've been telling in the past 5 minutes. You move around the Earth.
Oh my god.
Going north or south.
You do it on purpose.
And you measure.
Are you not understanding me? Are we
You're asking the same fucking question.
Are we having a language barrier?
What's he supposed to fucking answer?
Right.
I guess I'm not understanding you. Please reformulate.
Okay. So you have inside on a computer, inside your house.
Yeah.
And then you can go on a computer and you can say, look, this is the ball if I do da. Yeah? Now, go outside your door. You have a door?
Okay, now maybe I understand. So
I knew it. You didn't understand what I mean. You see, now open your door to your house. Yes. And go outside into the fresh air.
I didn't specify that part. So the astronomers, when they looked at the sky, they were not inside and looking at the computer, right? Because if you are an Inca...
No, I didn't ask that. I said... No. See, you're missing what I'm asking. Do we know of anybody, or you know of anybody, who has been outside of the house and measured the ground to be curving? The ground,
yes,
not the sky. The
thousands
ground.
Of people. Why not the sky?
We're looking for the curvature of the Earth.
And you can measure the curvature of the Earth by looking at the sky, moving on the Earth and looking at the sky.
Go on then.
Why don't you understand that?
All right, go on. Walk outside. What's the first thing we're gonna do?
Yes, I explained this in the video, so I can take the time to explain it again.
So I go outside my house, I walk outside, I'm in the streets, now what?
Right. So you have friends, right? You have friends.
All over the world.
They are like every 100 kilometers south from your position. You position a friend, and you tell them on that day and that time, right, in the same hour, like maybe at 2 a.m. in the night, because of course all along the same line in the south, if you go south, except for the polar regions, everyone will be at the same time, right? It's a meridian hour. Okay, so you ask your friends to take a picture looking at the south, and you have just the horizon at the lower part of your picture and just the stars above. And all these friends, 100 kilometers, every 100 kilometers down south, they took all these pictures. And then you take this picture and you make an image sequence, like a movie. And you see how does the sky behave as the position on the earth change, right? This observation, anyone can do, right? It's been done for thousands of years. This observation needs to be understood and explained, like on the flat earth. How do you explain this observation? Because the observation is that the sky rotates exactly as if you would be traveling on the globe, right? So the globe model is completely explains perfectly every observation you have in the sky, everything. I don't understand how it works on the flat earth, like, and this model that you shared, the web page that you shared, it's interesting, but the stars, how they model the stars is completely wrong. Like, doesn't make any sense. It's not. It doesn't have anything to do with normal observation.
Okay, so let's start again. I'll go outside. We're together. You're gonna walk 100 miles away from me, by car, by bike, by plane, however you want to do it.
Mm-hmm.
How are we going to determine there is physical obstruction between? Let's say we're going to go over water. We're at the beach. You set off over the water 100 miles away.
We don't need, at this moment, we don't need to presuppose that there's a physical obstruction. We could very well be on the flat earth.
No. I'm saying in the real world, you go away from me 100 miles over the water. Where does the curvature come into play at this point? You're just right in front of me, but just 100 miles away.
Well, you can measure it with the difference in angle of the star's angle. You can measure
but I'm
how much.
talking about that. Look, if I stand in front of you, at what point is the Earth curving between me and you? We're in a boat. We're on the water.
If
I go one way, you go the other way. At what point does Earth start to curve?
Maybe I can answer this way.
Yeah.
This image sequence that I was talking about, if the angle of the stars move regularly, on a constant rate with traveling, with distance, then we can. It's indication that the curvature is constant. So then it answers your question. Like, then we can know that if you're 100 kilometers away, then you will have this amount of curvature, like this angle between you.
Okay, so what is it between 100 miles?
You need to divide by pi, and then you divide by
come
the
on, now,
distance.
let's do it. Let's figure it out. Let's figure out how much curvature should be, because we're going to reduce it and get smaller and smaller, up to a mile. Yeah? Mile to 100 miles.
No, that's just the. Like, yes, the angle in the stars you will reduce it as you reduce the distance between you and the second observer. Yes, I agree.
But I'm trying to explain to you, if there was no obstruction between me and you, we can see one another along the horizon line, but your stars are saying that there is curvature. How do you...
Well, yeah, but the thing is, when you look at the horizon, you look through atmosphere, right? So the light rays are interact with the atmosphere. So you need to take that into account in your model. But when you look at the stars, you just have the very thin layer of atmosphere above you, except when the stars are on the horizon, right? But if the stars are up, then there's much less atmosphere with which the light from the star interact. So the accuracy of the simple model would be better, but on the horizon, then you have to take the atmosphere into account. You see what I mean? So
yeah, so like the stars tell us that there is curvature between an observer at 1 foot and 1 mile away. There should be curvature. That's what the stars tell us.
Yes.
But in
You see
reality, we can see beyond that 1 mile, and we can see further. How do you explain that?
Well, then I see two explanations. The first one is there is some kind of this is what we were talking about. There's some kind of something that disturbs or deforms, like a transformation of the light that comes from the stars, that explains everything that I was talking about, like the fact that if we are on different part of the Earth, then the angles with the star are changing. So you have to explain this on a flat Earth, or it's the opposite. It's like the measurement of the angle of the star. That's okay, but then there is some kind of transformation of the light when that goes through atmosphere. This is why you see.
I know that. I'm not arguing that. My argument is stars tell us there is curvature between the 1 foot observer and the 1.22 mile horizon. There should be curvature. Stars are saying, yeah?
I'm not, if you are on top of something that curves away from you in all direction, then
like for example,
how
do you see text chat, yeah?
Yeah.
So you see, like, there's the horizon, right?
This oil rigs.
Yeah.
That's the. So what are the?
No, the
what
horizon, the water, the horizon line, yeah.
Yes.
So
Okay.
the stars tell us that that's where the horizon should be, and that's where the curvature begins, right? For that observer. So when he's looking, the Earth he can see the Earth curving beyond that point. Things will disappear beyond that horizon, yeah?
Yes. If there's no transformation of, if the light rays are not bent by the atmosphere, because if they are bent with the atmosphere, then you will see much further than what you're supposed to see. You see what I mean? On a simpler model.
Look, I'll show you this here. Look, take a look at this. So if we're looking along that red line, right? Then?
Yes.
So we're looking along that line. The stars tell us that after 1 to 2 beams, we won't see the Earth anymore, right?
1, 2 beams.
Yeah, you see the first beam, first straight vertical beam. Sorry, the first vertical.
Yeah.
Then you have the second one.
Yeah.
Along the red line, that is. And then by the third one, you can't see the Earth anymore, right?
Why?
You're
You are
looking along
on
that
the
red
Earth.
line.
Why wouldn't you see the Earth if you're on the Earth? I'm sorry, I don't get it.
Picture.
Yes.
So you're
It's very
looking
small.
through that red line, like a telescope.
But here the red line is a straight line.
Yeah, you're looking through that straight line.
Yeah, but that's what I was saying. If the lights are bent by the atmosphere, the light wouldn't be straight. Then you have to bend it as well.
No. This straight line is our tangent line.
Okay, so it's a abstract line. It's not the light rays.
No, it's just our line of sight.
But the line of sight is the light rays that come to your eye.
So are
So
you saying
need
that
to
at
take
some... Okay, so are you saying we would be able to see the other side of the ball if the light rays were correct?
If they are bent enough,
Yep.
in theory, yes. But I think the atmosphere doesn't bend the light enough so that you can see the other side of the Earth, right?
But in theory, if, say, we saw the other side, you would say, well, that's just the light bending around, yeah?
No, I mean, it would be. It's an interesting question. Like if atmosphere bend the light enough so that all horizon around the globe look like it's flat, so that I like if I could have a perfect vision and no obstruction, I could see the other side of the globe just looking at the horizon. But still, moving on the Earth, I would see the angles of the star changing as I move around. Then
No, I
I
know
would
that.
have
I'm
to.
just saying that the light on the Earth, you're saying, could make us. It could bend that extreme. We could see our backs, like behind us.
Yeah, that could be great. I don't think it's not the
Theoretically,
actually
the
it's not
light,
the,
like that, theory is possible. The refraction could
yes,
happen.
there are experiments where you see that they have prism with very high refraction index. They send a light beam, and the light beam bends around the prism, and the prism is like in circle, and the light beam comes back to the source. So in theory, it's possible.
Let's have a look at that.
You ask me much, I will make a quick search.
Yeah, have a quick search. That sounds wild, but doable. Let's take a look.
High refraction index.
You're saying they took a ball and like bent the laser all the way around the ball or something?
I think I remember, yes, something like this.
Wow. Get a gander of that. What's it called? So I can search.
Well, the basics is refractive index and light bending, or
Yeah, you can just look up like any refraction video. It will show the same thing.
Trying to back up his claim. Monkeys.
yeah.
I'm
I
sorry,
hope
I didn't mean to jump in.
Oh, you can jump
hope-
in. It's not a one-on-one.
I hope I can find it.
I hope you can find it too, because you're saying light can bend all the way around in your model. Is that a practical thing?
Well, if you'd like me to interject there, light scatters in all directions.
Because
Yeah?
light moves in straight lines, the tenor.
Bollocks! The sun is a fucking ball of burning gas. Do you think it just beams in one direction? No, it doesn't.
Now don't
It
don't
fucking
jump
beams
in.
everywhere.
Don't jump in. Let them talk.
It's
Well,
fine.
go on then. Yeah. Sorry,
Talk,
I'm
obviously,
telling you
while
too
he's
much.
looking for this thing here, Monkey.
You're learning too much from me. I'm gonna have to be quiet now. Sorry. You know, you're gonna have to learn it on your own, because that's not the way it's done in this room. You've got to come up with your bullshit, hope that you've got it right, and then be quiet about it. Because if you start talking about it, oh, you can't talk about that. No, sorry, that's the real world. We can't talk about that, Chemo. Sorry. Keep on the flat fucking subject.
You found it yet, Latinia?
No, I'm still looking, actively looking.
Ah. So in the meantime, let's scrap that argument then, and we can focus back on this image, right? We can't verify this light bending extremities.
I'm keeping my gob shut on that one.
That's pie in the sky at the moment, yeah? At the moment. Pie in the sky. It's a made-up
Well, I
concept.
could destroy your conversation, Chemo, but I've been told to be quiet, so I'm not gonna.
Oh, you're free to do free.
Well, it means
This.
But Latenia,
I know what game you're playing anyway, so it's irrelevant to me actually telling you what I was going to tell you in the
you
first
found it,
place.
yeah?
So there you go. So it was a pointless fucking thing to do, really, wasn't it?
So in this, I don't know if you see.
I can see this, but this is not going around.
Yeah, it's not going. It's bouncing and then refracting and then bouncing and then refracting. But then I guess.
What medium is this?
Let me find out.
Is it sugar water?
This next picture depicts the bouncing laser beam in action with help of an advance. Yeah. Wave dampening. Which medium is that? Good question. Water.
I mean, obviously, it would need to be able to,
vanilla extract.
Sorry?
Corn syrup. Carolite corn syrup.
What is that?
No vanilla. here.
What
It
is all
gives
that
instruction.
stuff?
It gives instruction how to get to the.
No, just
to
what's the
produce.
name of the medium? What is it? What's in that medium?
It's
Sugar?
corn syrup. Corn syrup.
Syrup?
Yeah.
Sugar.
Apparently.
How about you do it with
What's
Curvature?
A bit of there. A bit of there. That's a bit
You
boring.
said
What
the
is
you said the light in the atmosphere can bend like this. So why don't you test it with
I'm not familiar with the word air.
Breathe yeah?
Air. Ah, okay.
What's
Sorry.
Why don't you test it with
Yes,
air
air
is-
doesn't have the same refractive index, right?
Sorry?
Air doesn't have the same refractive index.
But you
Don't
just
it?
said light can bend around the ball.
Yeah, if air had such a great refractive index, that's what I was saying.
Depends
If the
what's in the
atmosphere-
air, doesn't it? That gives
I
it the
understand what you're
refractive
saying now.
bloody
You were
index.
presenting this because you're saying that light can bend in the air around the ball. Now you're saying air cannot bend light around the ball.
Yeah. Well, that was my point all the time. Like,
Well-
if the atmosphere had a refractive index such that it could bend lights along, like with the same kind of rate as the rate of the angle change of the stars when you look at the
Mhm.
stars, then in theory you can see your own back. If you had no obstruction.
Yeah, but we've just
and-
established that air cannot bend a light like that, yeah?
Yeah, I don't think it can, like, because we can
Well,
measure the
you
refractive
just,
index.
you just showed syrup, sugar.
Yeah. We don't live in syrup.
Alright, so
I
let's
agree.
go back to this image now then, alright?
Yes. So this is incorrect, because then you have to calculate the refractive index of the different layers of atmosphere that your red line goes through and bend it every time according to the refractive index, right?
Where's your experiment to show us how much refraction can work or not work?
That's easy. You have vacuum. You point a laser into vacuum.
Okay,
and
let's
then
take a
you have-
look.
Say again.
Let's have a look. Keep making these
Refractive.
wild claims and not being able to support this. This is not a religious group where you can just give me your cultish belief. You have to back up what you say.
Why I did with the previous one, didn't I? So
No, you
refractive
provided
index of
syrup.
air. Yeah.
Don't
I
live in
said
syrup.
I said refractive index. I said medium.
Yeah. So can you demonstrate the light bending around the globe with an experiment?
But I didn't claim that the light could bend. I said hypothetically. I said in theory, if the
Right, so let's
refractive
go back
index
to my
of the-
image then. Put down the hypotheticals, the theories, the assumptions. We're going to go with the really
Yeah, but
is.
you,
right?
you okay? If you take your picture with the red green Earth and the red line, like this picture, the last one you shared, right? So this picture represents a model, right? If
Yeah.
you refuse the ability to make a model, then I have to refuse the ability to even
No,
analyze
no,
this
no,
picture.
that's
right?
what we were told, right? We can go with the globe information because that's what we were told. We weren't given a flat Earth model. We were given a heliocentric model, right? Now, if the Earth, look, let me show you this Mulder's Toland. Read this. Have a gander at that.
Is
Read
it?
it?
No, it's too small and it's blurred. Do you have something better?
It's not very clear. But basically, Mulder's Toland is, if P, then Q, not Q, therefore not P, right?
Yes.
You
Isn't
understand
that
all that?
modus? Yeah. That's
Yeah.
modus tollens. Modus ponens is if Q then if P then Q. P therefore Q.
Yeah. So, if the Earth has a radius of 3959, what letter is that?
What
What letter is it?
letter?
Here's 3959.
That's
What are you
right.
talking
if,
about?
If
That's your hypothetical.
Yeah, we're
that's
doing the
P.
Mulder's Toland.
Yeah.
So, if the Earth is 3950, the radius is 3959, what's
Yes.
that? What letter
That's
is that?
P.
That's P.
That's P. Yeah,
Yeah.
we agree.
Yeah.
Okay, you can go a bit faster if you want. Huh?
What?
You can go a bit faster if you want.
No, just so you understand. So, like,
Yes.
where should the geometric horizon be?
Geometric horizon being.
If the Earth is a globe.
Yes. What is your definition of a geometric horizon?
So
It's
it's
the
where it's the place where it's the edge, basically, of where things disappear and cannot be brought back because of the
Yeah, so it's the furthest point you would see on the sphere if you live on the sphere, right?
yeah. If you want a sphere,
Right.
and it's 39,
So the
59.
heliocentric model doesn't claim that you will see exactly what you
No, it's not about what you would see. It's about the position, location of something. It's not about refraction. It's about if the Earth is an actual ball with this radius, then the geometric horizon, regardless of atmosphere, the geometric horizon will be 1.22 miles away.
Okay.
Regardless of the atmosphere. Yeah?
Okay.
So, where is that geometric horizon?
Do you want me to do the calculation right now?
No, we've already done the calculation. Where in the real world has the geometric horizon ever been located?
I don't. That doesn't make any sense. The question doesn't make any sense.
So we're told that there is curvature. You know how we went through 100 miles?
No, but you're in the UK. You don't see the Mount Everest, right?
Because of apparent obstruction.
Yes, I agree.
Not
So
physical
you
obstruction.
you have to first determine that the apparent obstruction will not prevent you from seeing the geometrical horizon, right? Do you agree with this?
Look, let's take a look at this image here.
More
Got another
image.
one for it. See this one?
Yeah, nice.
Okay. So on the left, got the as you go higher, Earth is supposed to
Your horizon should go further, right?
drop away. Alright? But what we find is that the geometric horizon, okay, moves like it's the apparent horizon. And with the apparent horizon, we can't make measurement at any problem for.
With the apparent horizon, we can't make measurements.
No, because the Earth doesn't curve beyond that horizon.
I'm sorry, I'm not following. So
look at this image. The image I've just posted.
Yes, there are two parts. There's a part with the balloon and a part with the.
Oh yeah, we just want the first part.
Yeah. Okay. So the part with the balloon.
Yeah, the part with the balloon.
As your elevation increase.
No. Look at the horizon. So just look at the image as it is, and then look at the horizon. See that line, that white line?
Yes.
So on a ball, the Earth is supposed to be below that white line.
But no. The white line is the horizon, so it's the same place as the where the sky meets the Earth, right? This is how you define horizon, don't you?
The horizon will always stay at a perspective distance to the person that is seeing it. No matter if you're walking towards it or walking backwards towards it, the horizon will always be apparent to the distance of your perspective.
I mean, this is one of the hardest arguments to understand.
Yes. So the image on the left doesn't make any sense. I don't understand what it's trying to express. The horizon is defined as the furthest point you can see on the Earth, right? This is where the sky meets the Earth. So on the left part, the you see the horizon seems to be going down, right? And the white line, what is the white line? It doesn't mean anything.
That's what we
what the
see
fuck
on
is
a
the-
flat plane.
Say again?
On a flat plane, we see the image on the right.
Yes.
In reality,
But
on a
also-
ball,
also
you're
on the-
supposed to see
Also on the ball. Also on the ball if you are in a very large ball. Like the first few kilometers you will basically see the same thing.
No, on a ball, you're supposed to have curvature.
No, but here they show on the left, they show the horizon going down. This is on the Earth. That would be like if you go tens of thousands of kilometers away from the Earth, right? You will start to have this effect after tens of thousands of kilometers, like the geostationary satellites. Even on the ISS, they don't see the horizon curving down like this. Doesn't make any sense. Like
It should
if you're on an
happen.
airplane, you don't see the
If you were
horizon
really on a
curving down.
ball, that would happen as soon as you see the horizon. Immediately.
Well, yeah, but it's completely negligible if you are just a few kilometers away from the surface.
Look, remember this red line? There we go. If you were looking along this red line at that image, you'd start to see the ball drop underneath you immediately.
Yes,
The thing
but
is, Chima, is you can't
the-
detect the horizon on a radar. You can only see it because it's only apparent. There you go. So it's an illusion, in it? It can't be detected by any means apart from what your
Thanks,
eyes are
Terry.
seeing it in the
So-
perspective of what you're seeing it. Do you get me?
on your diagram.
All right,
with,
look
with
at
the-
Terry's
with the green
made us
arrows.
an image. All right.
Right? Yes.
So look
Thank you,
at
Terry.
the two images with the red line moving really quickly.
Yes. So look at your diagram. Okay. So the red line compared to the curvature of the Earth, the Earth is in green. Do we agree? The ball theory, yeah.
No, look at both the balloon and the one with the red line.
Yes. I'm addressing your both these images. Okay.
Right.
So in
Look,
your
so
in your
listen. If we were to look at the image on the left of the balloon with that red line, where would we be looking? Straight ahead, right?
So
To that
the
horizon.
left image on the balloon. What is the white line? What is this?
That's the horizon.
No, the horizon is where the Earth. So do you have water between the white line and the squares?
Now that's your eye level.
Your eye level.
Yeah.
What does that mean? The eye level.
When
How do
you're
you
standing,
determine
when
your eye
you're
level?
looking through the red line, how many times have I explained? Look at this
Right,
image
right.
here.
So
This
this
red
red
line, okay, is where
So
you're
this-
looking through that red
yes,
line
I'm trying to address your point.
Right. So look, let me explain. You're
What
looking through.
what is the elevation of the starting point of the red line on the left side of the image?
Give me any height.
What is the
any height you want.
Yeah, but do you understand that if you bring the red line closer to the Earth,
Mm-hmm.
then the apparent curve of this green line, the line that makes the difference between the green and the white on your diagram, this will straighten, right? As you go further towards
No,
the
that
Earth.
line, that red line is going to stay straight, horizontal
Yes,
the
but
entire time.
the green part will become then like a straight line.
Why?
Because if you reduce, I start again. If you reduce the elevation of the starting point of your red line, then it will go closer to the green disc, right?
But the red line is going to
if you
always
if you zoom in, then
listen. It's like a tube, yeah, or a telescope. You have a line of sight down that red line. You're not going to look anywhere else, so you will only see through that red line.
you said that there is obstruction to your vision. Do you agree with this? Still?
No. Look, we're looking down
No,
that red
you
line.
don't agree with this anymore.
See, why are you struggling now? You're looking through that red line.
I'm trying to make a point, but you don't understanding it. You're not understanding it.
I don't
On
understand
your
it. No. Take
you
a look
don't
at this
see forever. You
basketball
don't see
picture.
forever, right? So the red line, you say it's your eye level, but your eyes can see until you have obstruction to your sight. So you have to
Well, you
reduce
can see
the
until
length
things
of
get
your
smaller,
red line.
yeah?
Say again?
Until things get smaller and smaller perspective.
No. You said the reason you don't see the Mount Everest on the flat Earth is because there are obstruction to your vision. It's
Well,
the highest
obviously, 'cause
mount on the
it's-
planet, right?
Obviously,
So
because
there's
of perspective as well, yeah? Can't see that far.
no, but no matter its perspective, if it's the highest point on the planet and the Earth is flat and you have no obstruction to your vision, you will see it.
How? How
Simple
can you see if it gets smaller and smaller the distance?
because it's the highest point.
But things get smaller and smaller in the distance.
Yeah, but everything gets smaller. Like if you don't have anything that is in front with the Mount Everest and that is that obstructs your vision, right? You don't have another mountain that is in front of it and is bigger. Like if you have a straight line, then
Yeah.
you will see it, the Mount Everest.
But that's not
You think
true.
Okay, why not?
So let's take, for example, the straightest road in the world, in Canada. Yeah?
Okay.
So it's going down a slope. It's like 100 miles plus. Straightest road. It's been measured. It's in the Guinness Book of Records. Okay? And?
Yeah, it's crossing Saskatchewan, Alberta. It's going from Ottawa to Calgary or something like this. It's this one, right? Anyway, go on.
So you're saying on a straight road you would see from one end to the other if it was straight?
No, I'm saying you can't because the atmosphere, when it stacks up, then
So why can't we
it
see
blocks-
Everest then?
on the flat Earth,
Mhm.
you wouldn't see Everest because the atmosphere itself obstructs the light, right? So there's a distance, a limit. Like if you go to Tokyo and if you have a good vision, good visibility day, you can see the Mount Fuji, the volcano, right? It's very
what's
far
your
away
point?
and
I
it will
don't
be
get-
faint.
Why are you
It will
making
be-
double arguments then? Either the red line can see or the red line
Yes.
can't see.
I'm going back to the topic of the red line. So this red line, you need to reduce its length.
No, we're not going to
to-
reduce
to the-
anything. We're going to keep everything the same. So you're looking through that red line at the image on the left of that with the balloon.
Yes, and why isn't there any obstruction from the atmosphere then?
Because you're looking through a tube,
A what?
a vacuum. Like
You're
LIGO.
looking for a vacuum tube.
Yeah.
So,
Sure,
so
why
this
not?
you're talking about reality and the real observations that we make in the real world, and then you're talking about a million kilometer vacuum tube. What are you talking about?
Well, you're talking about seeing Everest. Nonsense.
On the flat Earth,
Yeah.
you would expect to see that if you don't have obstruction and if the atmosphere doesn't. I was trying to make a point. I don't think you're following.
No, I'm not. I'm trying
This
to,
red
I'm trying
line,
to explain
this
to
red
you.
line is meaningless if you don't take into account the atmosphere. Completely meaningless.
Well, how have
on
you
your
taken
diagram.
into account the atmosphere? What does that
You have
do
to
for
take
you?
into account the fact that the light is bent by the atmosphere. So the refraction index of different atmosphere layers that this red line goes
You
through.
haven't
You have to
demonstrated
bend
that
it.
there, remember?
Say again.
You didn't demonstrate that part. That's
You
not the
want me to
real world.
demonstrate that air has a refraction index?
Did you demonstrate that?
It's done by any high school physics
Excellent.
class.
Let's
I
take a
think,
look
no?
then.
Right. Okay. Demonstration.
I love it when Chemo says, "Let's have a look then."
Because if someone's just going to make wild claims, they think, you
Well,
know,
the
I can just
well,
say
the problem
wild
is, Chemo, when
things and
you
then,
say, "Let's have a look,"
you know,
then
that's
I'm pretty
me
sure
done.
you've
And it's
seen.
like, well, hold on a sec. None of what you've said has ever been verified. Just
The refraction index of air? Are you serious?
I think there's an entire study.
yeah, what is
done
the
about
refractive index? How are you working these things out?
You measure the angles of the rays, the light rays.
You measure the angles of what?
Light rays as they go through one
Of light
medium or another.
rays. How are you measuring the
Say-
angle of light rays?
By optical systems? I don't know
God.
what.
Well, let's just take a look.
This
Let's
is
have a
the-
look at what you've done.
The problem is that I don't think Chemo ever researches anything.
Well, if it's not worth
always-
researching, then
Well,
it's
you
not
always
worth
say,
it,
let's
right?
have a look.
You don't want to waste your
Let's have a look.
time researching things that are not relevant.
Let these two talk. They're talking.
The refraction index of air is not relevant to the red line.
We don't know yet. Let's see. Let's have a look at your demonstration. Might be, it might not be.
Given given atmospheric conditions.
You seem to be
You think
struggling
you-
to find any evidence to support your claims.
Well, you gave me 2 minutes, please.
Probably just a Google search away.
Wider vapor. It's not
So
very
look,
clear.
let's go. While you're looking, can you look back at that balloon picture that posted?
Yeah, but I'm sorry, I cannot do two things at once, right?
Oh, okay.
I can send you a private message if you want. Like
No,
the
no, it's
refreshing
fine,
index
take
of
your
air
time.
is.
No
So
rush.
one Google search away, Chemo. Refraction
Yeah,
of
we're
light.
looking for the demonstrations
Refraction is the
of your
bending of light.
explanations.
Also happens with sound, water, and other waves, as it passes from one transparent
Standing.
substance into another.
One.
You know when people wear
Two.
glasses?
What?
That's refraction.
No, but
That's how we know
he
about
did-
refraction.
he never said he was unaware of refreshing index. He's talking specifically about the air, because maybe he thinks the air doesn't refract light.
Well, again, I'm not denying or confirming. I'm just saying, let's take a look at what you know.
Yeah, that's fine. That's completely fine. Uh,
The fewer claims we make, better our position. You know, you can't attack us.
parsimony.
But if you make lots of claims, then obviously we can jump all over those wild, outrageous claims, right?
Of course, let's not make any claims. That way we don't have to back anything up. right?
Exactly.
Is that your stance, Chemo?
Well, precisely. If we make few
Oh,
claims,
okay. That's a great way to have an argument.
but we're not making any claims, duh.
Right.
You are.
So
You're
you don't-
claiming
so
the
you don't-
Earth is a
So you
ball
don't have,
spinning,
so
flying through
basically you don't have an
space.
argument.
What?
So you don't have an argument.
What you say, Renee? No, that's Tom. Yeah, I mean, look, our argument is very simple. Water cannot curve around the exterior of an object without a force. So without that force, it's cannot happen. And we know gravity is not a force, an apparent force. We know acceleration not actual, apparent.
Are you okay with public peer-reviewed published scientific papers?
No,
What do you need then?
they are just religious papers without demonstration.
Do you need like
Hey, those papers
a
are
video of an
based
experiment?
on- Yeah, those papers are usually based on experiments that have been done.
Yeah, that's what you always say. No, we're
That's-
looking for practical
how science
elements,
works.
not just repetitive rhetoric.
Science
Litania.
is not just YouTube videos, Chemo.
Yeah. If it's not on
pretty
YouTube,
pictures.
then no. Okay. Everything but everything. NASA is on YouTube. They put the flight into space on YouTube. Lots of science. Everything's on YouTube. I mean, again, the way you try to put YouTube down and say, "Oh, it needs to be on
Nobody's putting
YouTube."
YouTube
Yes,
down.
it needs
You're
to be on
saying
YouTube.
there's other places to find this evidence
Where?
instead of just
Where?
pictures and YouTube.
Where, for example?
No, well, see, this is the point. You're asking me, but this just shows that you don't do any research.
I mean, again, look. If you think you know something that we don't, let's take a look at how you know that something.
Oh, but it's I like your challenge, because if I don't find such video, then I have to make one myself, right?
Of course, we're not just going to blindly believe in your
Yeah, yeah.
religion, Litania.
Of course,
Yeah.
and I will never ask you to blindly believe anything.
Exactly.
Uh,
Exactly. So once we get, I
Well,
mean,
let me-
I give you an example. So I was saying, oh, you can't make rainbows with reflected light. And the boarders were like, what?
Rainbow?
Of course you can. And I was like, no, you can't. And
Rainbow, you said?
one of the guys here demonstrated it. And I had to concede. I was like, okay, I can see what looks to be like a little rainbow with reflected light. Pretty painful, but you got to deal with it. Now, rhetoric and poetry is not going to fly. You have to be able to provide something practical. Show that you know what you're talking about. Otherwise, you're just a parrot repeating what you were told. You see?
I can only find a peer-reviewed paper so far.
I know you can only find peer-reviewed papers. Yes.
I was say again.
I know. There is nothing practical in your worldview. I told you, your whole worldview is based on assumptions, based on not actual, based
Wait a
on
minute. Based on
apparent.
assumptions? Are you serious, Chemo?
Yeah,
Our
your-
worldview is based on assumptions.
Yeah,
Chemo,
your
your
entire-
entire model
Yeah.
is based on assumptions.
No, I
He's
mean
saying
your
you
globe.
got nothing.
You assume.
You got
First of all,
nothing.
you assume you don't know this the distance of the moon. You assume you don't know the distance of the sun. Also, you assume that it's small and local. You assume that the Earth is flat, even though you don't know how big it is. Your entire model is based on assumptions.
We don't have a model.
Exactly.
Exactly.
Exactly. That's the problem.
Exactly.
So you assume, but to think about how many assumptions you have to make
No assumptions, not
in
one.
order for you to believe the Earth is flat.
Not one assumption is made.
Okay, so what's the distance to the sun
Don't know.
on your supposed non-existent model?
No idea.
Okay, so you assume that people don't know the
No,
distance.
I'm,
To the sun.
I'm saying
Ah,
I don't know. If you know,
I have chemo.
what?
Sorry to interrupt. I have a so when the refractive index of air is dependent on the temperature. So when you have areas where the temperature is higher, the air will bend more than when it's a little colder. So when you do you know what we call a mirage? I mean, in French we call it mirage.
Mirage, yeah, okay.
Yeah, so this is like you have radiating temperature from the ground that modify the refractive index of the air above it, and this is what makes fluctuations in your line of sight, right? You see what I mean?
Mm-hmm.
The whole mirage thing is just modification of the refractive index of air with temperature, right? That's a demonstration that anyone, like any person that is more than 10 years old, knows what I'm talking about, right?
Okay. What's your point?
Can you still hear me?
Chemo, we're gonna have to put these guys to bed.
Well, yeah, I mean, again, I can hear from the tenor he's complete shock that his whole world supposed, assumed, and without.
Can you still hear me?
I can hear you, yes.
I
Uh-oh.
can hear you,
So
Chemo.
can you address what I just said?
Well, I don't actually get your point.
So you asked me to demonstrate the refractive index of air.
And you did it with the mirage.
I do it by putting something that is hotter and then something that is colder, and see that the light is bent. Like it varies. Right? There's fluctuation.
No, I'm
there's
not
the
arguing
temperature
about
varies.
that. I know about mirages. I'm talking about
Right.
light bending.
This is a demonstration of
No.
the refractive index of the air.
No. We're talking about light bending around curvature.
Yes.
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 It's
The
well
light
known.
is bending. A mirage is a light bending.
Not
It's
around
well known
curvature,
that
it's
light
not.
bends for the denser medium. This is a well-known fact.
But
You
it's
know
not
how
around...
you cover up on your bed?
What are you? What?
Go ahead, Super Fluff, yeah, go on.
I don't
No,
understand
he
if it's
doesn't really add
if it's
any.
a lack
Superflirt doesn't
of
add anything. Go ahead, I'm sorry.
at this
You
point
know
I don't know if chemo has a lack of
No.
like basic physics knowledge or you just don't understand
It's
the
a
point.
lack
That
of
would-
understanding. Yeah,
that
I'm a
would
flat
that would
earther,
it would seem like that,
Lieutenant.
right?
You've got to
It really seems
take
like
He
that.
has none.
You know how
He
to
doesn't
get
understand
in
any of
your
this stuff.
blanket?
I'm
He's
not
been
claiming
answered
to
this
be
question
wise
for
or
years and
intelligent.
Just let me,
years.
please, guys. Chemo, how do you explain mirage? What is a mirage for
No,
you?
look,
I'm gonna talk you into it.
I'm not
He won't
claiming
answer
to
it.
be wise, intelligent, or like a guru or anything
That's
like
the
that.
truth.
Okay,
So
I'm
you
just a
don't have an argument.
very, very simple guy who's looking for evidence
That's
of
fine.
a
That's
globe.
fine.
Okay,
That's fine.
so now understanding your model and your worldview is very difficult for me because there is no practical demonstrations of what you say.
Garbage.
Yeah,
Pure
you're
garbage.
You know that
dodging.
Pure
box
You're
you
dodging.
sleep on? Call
Chemo,
your
Chemo,
Now-
you're
bed.
dodging.
Obviously,
Please
you know,
answer,
we could.
answer my question. How do you explain for yourself mirage? What is it for you? How do you explain it?
Well, it's just like light, temperatures, giving the illusion of seeing something that is not in its actual position, or if there at all.
Right. How does that work? How can you
We've
see
just been
an
through it,
illusion
haven't we?
of a
We've just been
position?
through the different temperature variations. But I mean, again, when we say mirage, are we talking about something that is there or not there?
No, just as you said, it's an illusion that transforms the location, the apparent location of something, which is exactly what happens with horizon.
I mean,
It transforms the apparent location of the horizon.
well,
Precisely the same thing. This is why it's not exactly like the geometrical one
yes.
that you
So
calculate
if
with the
the
model.
horizon is like a mirage, an illusion, how
Yes.
are we making measurements to it?
Because we are measuring the angles between the stars, right?
Yes, and like I've said, those angles tell us there should be curvature from this point to that point. Yeah?
Yes, and in your model, you need to take into account the amount that the light is bent by the atmosphere.
Well,
Okay.
refraction does occur, but normally wouldn't you expect a discontinuity or a reflection to show that refraction is occurring the way that they're talking about? Like with a straw in air going into water, you see a marked discontinuity between air and
the
water.
discontinuity is because there's a discontinuity of medium, but in the atmosphere it's a gradient. Like you have a different concentration, and you go up in elevation, you have lower concentration, right? So there's no direct medium transformation. It's a gradient. So this is why you don't have the
So
straw.
shouldn't we see several reflections and several discontinuities then?
Reflection happens when you have a discontinuity or a reflective surface, right? What is the reflective surface on the atmosphere? There's no reflective surface.
A reflective media. Refraction is usually going from medium to medium, like the straw in the water.
So, did you see the laser, the green laser rays that were bending that from earlier? Or should I post it again?
From the sugar water?
Yeah. Do you see that? Right. So the light
I've seen it before.
The light that is curving, there's no. It's just a gradient in the medium, right? There's no medium change, and then as the light is coming to the limit of the recipient of the container, then it bounces because it's there. It meets a reflective surface, but then it bends downwards. There's no reflective surface. It's just refraction, and then it reflects, and then it bends, and then it reflects, right? So this is more like a third year physics in college, because this is interaction. It's a radiation matter interaction. So this is a bit more complicated. If you want to go into detail on that, it's much harder. But if you understand the concept of mirage, like exactly as Kimo said, it changes the apparent position of something, which is precisely what happens with horizon. Right?
I'm not arguing that. If it changes the position, how are you going to measure to the physical one?
Because you make a model that allows you to make predictions. The problem is that the temperature of the different layers of atmosphere that your line of sight goes through, it's hard to measure because you have to put somebody to measure the different temperatures, and you have to measure also the water content, because if you have water vapor, it impacts on the refractive index as well. So you have to measure the humidity, like the
Look at this image again of the balloon.
Yes.
Yeah.
So the image on the left corresponds
Hold on. So you see,
Sorry.
like on the right, image on the right, right?
Yes.
So if we stay in one position and see that white line can be 1 mile away. Yeah.
What
do you
produces
understand?
this what line? What
The
is it that
white
produces
line
it?
going across the middle.
Yes, so it's an abstract line. It's not something that you expect to see in real life, right?
That's what we see when we go outside. We see that horizon line, right?
On the right side,
No,
you would
on
see it,
on the right side, yes.
but not on the left. On the left, this white line represents nothing.
Yes,
It's
but on the
completely meaningless.
right, that's what we see. Yeah.
Yes.
Right. So if we're on the ground or in the air or wherever we are, and that white line is 1 mile away. And
Yes.
so we're in our position, anchored. We're not going to move. That white line is 1 mile away. Yeah.
Okay.
So beyond that line is the Earth curving away.
Possibly, yes.
Possibly. So we don't know. You see the image on the left. The Earth that ball is curving away, right? In some of my words, curving away.
Yes.
See the one on the left? It's curving away. Yes? So the image on the right, where the white line is on the Earth that we live on,
Yes.
is the Earth curving away.
Yes.
Like that.
Possibly.
Possibly. How can we ever know?
Many ways to know. Like, for example, you move around and you look at if there's a point in the sky.
Move around where? What's going to happen if we move around?
You move around and you see if there's a point in the sky that changes. That's indication that you're on a curved surface. If the point remains exactly with the same angle with the horizon, it's an indication that you're on a flat surface.
But
Especially
what about making a physical measurement? Is that needed at any point?
Measuring an angle is not a physical measurement?
No, not angles, just physical measurement. Like this device. Here, look. One with that red line. That is a device on the Earth. Now I understand you don't know what physical is. So imagine we built this device. This would be a physical measurement. Yes? No angles needed, no guessing, no assumptions needed.
What device? Which device?
Is that the chemo device?
You understand this is a physical apparatus, yeah?
Where? Which part? Which part is physical?
What do you mean which part? All of it.
It's a chemo contraption.
All of it is physical. We're going to make that red line in reality. It's going to be called force the line to be straight. We're going to force it so it's horizontal.
Sorry, if I can interrupt here.
Yeah.
If we keep the scale, right? If we keep the scale, you understand that this red line will be like, I don't know, 10,000 kilometers long.
Yeah.
Right. So you want to keep something straight for 10,000 kilometers.
Whatever the distance, so you understand the principle. When we mean physical, we mean physical, practical. Like you just said, what, build something 10,000 kilometers? Yes.
Yes.
A real device.
It's completely impractical. Building something that is straight for 10,000 kilometers? What are you talking about?
If you can read, it does say 3 miles. Yeah?
It's not to scale. It's impossible.
Yeah,
this
you
is
can
only
build
3
that
miles.
for 3
Look
miles.
at the curvature.
What?
Look at the curvature of the green Earth.
Yeah, over 3 miles, that's how much the Earth is supposed to be curving.
I don't see 3 miles. 3 miles is the red line?
You don't see 3 miles.
This diagram is too small.
Keep looking. Look around. It's like a game. Where's 3 miles? Try to find.
So yeah, this is completely out of scale. It's impossible that 3 miles curves that much. This is not to scale.
It's impossible that 3 miles curves that much.
Look at the curve of the green Earth. It's
Does
like going
the
from the
Earth
North
curve
Pole
over
to
3 miles?
This is like going from the North Pole to the Polar Circle.
No, but I'm asking you a
Thousands of
question.
kilometers. What are you talking about 3 miles?
Does the Earth curve over 3 miles?
Yes, but much less than that.
Yeah, but
much
does it
less.
curve over 3 miles?
If you do it to scale, it would appear completely flat.
Oh, so over 3 miles would be completely... Hold on, let's get this clear. So 3 miles would be completely flat.
I count in kilometers. I don't
roughly,
know, 3 3 miles.
3
of it.
miles, yeah.
3 miles
It becomes
completely
Just do
flat.
it to scale. Is that so difficult to make a diagram to scale?
No, I'm
This is
just,
not
I'm
3
just
miles.
asking you.
There's no
You're
way it's
saying that
3
this
miles.
is not the right scale because you're saying 3 miles, the device would show completely flat.
No, if you make this
Yeah.
diagram, let me make myself clear. If you
Put it
make
on the
this
Nevada
diagram,
salt flats
try
and then do it.
try to make this diagram to scale. Like you make a circle, and this circle has a radius of 6,400 kilometers, and then you try to make this 3 miles thing, and you look at your diagram. The green thing will appear completely flat. The difference will be absolutely negligible. So the red line will seem to be parallel to the. This is not to scale. This is very easy to understand.
All right, so look again to this horizon here on the left. How far would you say that is? 100 kilometers?
No. The on the left side,
Mhm.
to have this image. Well, is your camera angled, or is it like parallel to the tangent of the place where you are? Because the white line is supposed to be the tangent line, right? The abstract tangent
Yes,
line
but
from
we
the surface.
can't draw a tangent in the real world. That's the point.
Kimo, why are you posting? What is this?
I'm trying to make you understand. The left image, to see this on the Earth, saying that the white line is like your eye level. If you look straight, okay, that would be. So
Yeah.
this would be something you would see if you are like 1,000 kilometers away
Okay.
from the Earth.
Okay.
So way above any satellite, way above the ISS, way above, a bit under the place where the geostationary satellites are. But it would be you're very, very far from the Earth if you see this.
Okay.
Extremely far.
So you're saying that we're just too close to the Earth to see curvature.
Yes, because the Earth is very big.
Left to right, yes.
What, left or right?
Left
Well,
to right.
locally the Earth appears flat, of course, because it's so big. If you make Rupert Cow made a maybe.
Have
to
you
the
corrected
scale.
it, Rupert? Right, take a look at Rupert's one.
Yeah.
Yeah, but that's not. He's
that's
corrected,
way
but
better.
that's not what we see.
All right. Well, which one's the correct one then?
The other one.
The red one, the green one.
Wait, how do I go back up?
What?
Yes, the green one. Green one is correct.
The
It's not
one
to
baller
scale.
said it's correct. The other one said it's not. Which
It's not to
baller should we
scale.
listen to? Latinia.
Well, it's not.
Is he really a bowler?
Green one is not to scale.
Latinia,
that-
which
that's
baller should we
more what
listen
we
to?
see.
You or
I
the
don't
other
mind me.
baller?
I'm just making a spliff.
So the best way is if I do it myself, because I can.
Go on then,
I
do
can
it yourself. Do a force the line drawing over 3 miles and show me
God.
what the red line would look like. Yeah.
Can we go in kilometers? That's easier for everyone.
I can show. I have a. Well, no, I really don't. But Kimo, are you able to?
Right, we're gonna take a
do
quick
my
break now
screen?
while you get this done, Latinia, because we've been going for over an
Kimo.
hour now.
Yeah, I have a ruler and a pencil. I just draw a straight line. It's that easy.
Kimo,
This
are you
is-
able to see my stream?
Rupert Cow say this is not mine. It's from their site.
Not
Is
just
it
yet,
a
Beeble.
flat Earth site?
But Latinia, what you want to do is draw this force the line over curvature so show us how much curvature there would be over 3 miles, if any. Because then there would be no.
I don't know how to say it.
Mhm.
Why do you keep asking show how much curvature would be? Like a curvature. How do you know how you measure a curvature? Like if you are
How
on
do you
top,
measure curvature?
you measure it by if you're in topography, you measure the angles of a triangle, of an equilateral triangle. You see how much the angles vary from the 60-degree. Right. So this is the topological definition. Then
Okay.
you would have astronomical one, where like I said, you measure how a distant point change in angle as you move around that would be a measure of your curvature. How else do you measure it? Then you have if you're far enough, you can measure like the pictures of the Earth. You can measure the curvature like this.
Right.
You have many different ways to measure the curvature. If you want to do the Aristotelian one, but this is with the sun.
But this force the line way is not the way to go, right?
The what?
this diagram that I showed you is not the way to measure curvature. in your
It's
mind.
very impractical. You need to build a 10,000 kilometers a straight line.
So you're saying the
So
best
in
way
this
to
case,
do
in
it.
this case, it's
Or
You're
3
saying the
miles.
best way to
Or
measure
you could just
curvature is
use-
to
you could-
calculate
Or
it.
you could use either an auto level
Oh, Ginny's here.
or a
Ginny, you
total
should have
station.
messaged me. I didn't know you were here and mute.
I think you
That's
could use
I'm,
message
I'm
a
don't
talking
be
satellite.
about
like,
the
hey,
practical. I'm saying if you want to measure curvature by somehow measuring like something on the horizon, it's very impractical because you have to
Yeah.
calculate
So I'm not
everything.
arguing with you. I'm saying that you're saying the only way to measure curvature is either A, look at the stars, or B, calculate a presupposed ball. But
No, you don't
practically,
have to
you're saying this is impractical
presuppose.
to
You
practically
make an
measure the
observation.
curvature.
Yeah,
make
the first one is much more practical. Anyone can do it. The
So the
second
first,
one is much
I'm
more
just so
complicated.
Jin, I'm gonna hand it over to you. I'm just clearing up that you're saying the only way to measure the curvature of the Earth is to look at the stars, and the other way is just to calculate it based on Eratosthenes, which presupposes the distance to the sun
No, it doesn't
and presupposes
presuppose.
that is on a ball.
No, you like I said, you can also just move away from the Earth and look back at the Earth,
Oh,
like on your left picture.
or look back
But,
at the
but
Earth.
you have to go very far away, and then you will start to see curvature
Excellent.
much further than the ISS.